So I was just going to start by going through the objectives and just kind of, just talking about each lab. So the first lab that we did was rapid identification methods. And so in this one we did we didn't do the IMVIC test or the API test, but we did the NRO tube. And do you guys know what group of bacteria were the IMVIC test developed to separate?
Oh, yeah.
You remember?
I remember. This was pure torture.
It's not that bad. It's interesting. It's science.
I'm sorry. It was interesting. In Latin terms.
This? Intro.
Yeah, Enterobacteriaceae. Or enterics.
Enterics.
Yeah, just remember enterics.
Yeah.
That's an easier way. Okay, because that's how you know if water's been contaminated with sewage. So that's why we're looking for the enteric bacteria. And so what is the purpose of the rapid identification methods? Yes, Lisa?
I remember this. Okay, they did it fast. Okay, correct me if I'm wrong.
Uh-huh.
They did it fast because they wanted, it was commercial use pretty much. They had to hurry and figure out if, okay, is this going to be okay? Can you drink it?
Exactly.
So they made it quickly and kind of dumbed it down a little bit for everyone to
Made
use.
it really fast so that, so that you could tell if the water was contaminated. Exactly. And do you guys remember what the advantages of the Entero tube is over the IMVIC tests?
That's the.
Because the Entero tube was the long one with 12 different little compartments.
It was a fast one to tell you about different things.
And the
just fast.
IMVIC just had 4 tests.
It only had 4 tests. This one had so many other ones that you could see and you could tell if it was anaerobic or non-anaerobic. What is it? Aerobic.
Mm-hmm.
Anaerobic.
It's just a lot more specific. Like you can just tell, because with the IMVIC, this is just a small little graph of it, but it's like you do the IMVIC test and sometimes it would come up with a result that could be either this bacteria or this bacteria. So with the Entero tube, you can tell exactly what kind of bacteria it is. So, do you guys have any questions on 51? I would just recommend going through it again and reading through the steps and just remembering how you did it. And another thing to remember about the Entero tube is that you can inoculate all 12 compartments with just one little swipe of the bacteria through it. So. All right. Anything you want to add, Lisa?
Just, I don't know what it is, because he might have the Entero tube and you'd have to know how to spell it, or identify it.
Right, yeah.
So know what it looks like.
Yeah, exactly. Be able to identify it for sure.
Sorry.
And you don't have to know, he's not going to ask you, he's not going to put the Entero tube out and be like, what bacteria was this inoculated with? So, he's not going to do something really complex like that. So, okay. So lab 22 was the next one we did. Physical methods to control heat. So in this lab, it talks about the different types of bacteria that I think you guys have already talked about in lecture. So this is probably kind of a review, but definitely want to know the different ranges where the different bacteria, like to grow and that kind of thing. So that was the first objective. Know the different growth ranges for psychrophilic, psychrotrophic, mesophilic, thermophilic, and hyperthermophilic bacteria. So do you guys remember what the growth range is for psychrophilic in Celsius?
It's the really cold one.
Yeah, it's the coldest, exactly. It's colder than the fridge. So that one's 0 to 20. And then psychrotrophic, the trophy's in the fridge, so that's the one that's the refrigerator temperature. Which, do you guys know what that is? Celsius?
Is it 15 to something? I can't
Close.
remember.
It's 20 to 30. That's what the book says. And mesophilic, that's the me bacteria. That's the one. Those are the ones that get us. What's the growth range for that?
What is our temperature?
37.
Yeah. So in the book it says mesophilic can be 25 to 40. And then the thermophilics. You guys know what those are?
They're like warm thermals.
Exactly. So the growth range for those. Hotter than us, so 45 to 65. And then the hyperthermophilics are the ones that are just crazy. They're just grow in the super hot places.
Yellowstone.
Yeah, exactly, Yellowstone. So those ones are above 80 degrees Celsius.
One thing, if I remember right, and correct me if I'm wrong, but he didn't have, it's good to know, but if you don't know the exact degrees, it's okay, because he'll ask something, as long as you know what they mean.
Right, yeah. If you know like the basic,
Yeah.
yeah.
No, that's what I know. I don't know the specific.
Right,
Yeah.
yeah, so.
But he might ask for a
Probably.
specific
Uh-oh.
number, but
Okay.
as long as you know what they are,
Yeah.
then you.
Like I put one of those questions on the lab quiz, like that I think he would ask. I don't know. He's like I put thermophilic bacteria grow between what temperature ranges, and then I put all the different ones.
So as long
I
as
think
you know
you-
that thermophilic is going to be hotter than
Hotter, but
you,
not the hottest. Yeah.
Yeah, then you can pretty much use that.
Okay, so the next objective: know the difference between dry heat and moist heat, and which is more effective and why. So, can someone tell me the difference between dry heat and moist heat?
For sterilizing stuff,
Yeah, yeah.
the moist heat's more effective,
Mhm.
but the dry heat's like, I can't remember how hot, but for like 2 hours.
Right, it's 170
140
degrees for 2 hours. Yeah. The moist heat, yeah, moist heat is more effective just because it brings in another element. It brings in the water.
Steam.
Yeah, steam or autoclaving, pasteurization, and boiling. Those are all types of moist heat. And I think you guys probably talked about pasteurization in class already. So he's probably gonna maybe ask something about that. So know the different temperatures and times for pasteurization, boiling, and autoclaving, of course. So do you guys remember the different ones? There's 2 different ones for pasteurization. Remember what those are?
63 degrees centigrade for 30 minutes.
Mm-hmm.
Good job.
Yeah, that's
Great.
good. And then the
Warm.
second one's like the ultra high, short time pasteurization.
72
Mm-hmm.
for 15 minutes.
Seconds.
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 Yeah, that's
Okay, I
that's why it's so
just
short.
remembered half 30.
Yeah, no, that's a good way to remember it. Yeah, but just remember it's really short, so it's just 15
Okay.
seconds. And then boiling.
Shoot. I don't remember.
100 degrees, and that's for 10 minutes.
How many degrees?
100.
Oh, okay.
It says boiling for 10 minutes will kill vegetative bacterial cells, but it does not inactivate endospores. And so the most effective is, you guys remember? Autoclaving.
Oh, go ahead.
15 minutes, 121 degrees, 15 psi.
Mm-hmm. Yep, 15 pounds of pressure. Okay. And then in this lab, we also talked about two different things, thermal death time and thermal death point. And do you guys remember the difference between those two?
The death time, is that the one where how long it takes to kill 90%?
That is the decimal reduction
Oh.
time, but you also need to know that too.
Okay,
But,
that's the next question.
Yeah, that's the next objective. So, let's see, do you guys remember what we did in this lab with the tubes, and we would put them in the different temperatures? Do you remember that?
I do.
You remember that too.
Someone stole ours.
Someone stole our last one, so we had to use somebody else's.
Yeah.
That's funny.
Okay, so the thermal death time is the length of time required to kill bacteria at a given temperature. So that's the one where you just keep it at one temperature, and then you just keep testing it at different times to see when, how long it takes to kill them all. And thermal death point it's less common, first of all. It's the temperature required to kill all bacteria in a liquid culture in 10 minutes. So those are kind of similar, but it'd be good to know the difference between the two.
I always remember death time as it's a long time to die. And then thermal death point, it was the temperature that I would burn at when I died.
Oh.
I know it was morbid, but I remember that.
Sorry. You gotta come up with stuff to remember it.
That's funny.
Okay, and then the decimal reduction time, he'll definitely have a question about this on the quiz, so. That is the time in minutes in which 90% of the population of bacteria at a given temperature will be killed. So, so let's say, okay, so first of all, okay, so let's say you have 10 to the 6th bacteria. Do you guys remember how much that is? Because if you get that wrong,
One with
then
6 zeros. Right?
yeah, it's 1 with 6 zeros. So it's 1 million. Okay, so let's say you start out with 10 to the 6 bacteria, and it has a decimal reduction time of 1 minute when it's autoclaved. So, okay, so at 0 minutes, you have 1 million bacteria. And then 1 minute, 90% of this is killed, so you're left with 10%, which would be 100,000, because you just move the decimal over 1. That's how I do it anyway. That's how I just get 10% and just bring it down here, and then at 2 minutes, you have 10% of this, so that would be 10,000. 3 minutes, you have 10% of this, so that's 1,000. 4 minutes, 10% of that, so you have 100. 5 minutes, 10% of that, so you have 10. 6 minutes, you have 1. And then 7 minutes, there's 0. So that would take 7 minutes to kill all the bacteria. So he'll probably ask you something about this, but he'll use like a different death rate time. Like he'll give you like 1.5 minutes or something like that. And just remember to, just add it just by 1, or by each decimal reduction time. Does that make sense? Does anyone have any questions on that? Okay.
Just be really careful at the very first, because if you screwed up the first, you screwed up.
Yeah, exactly. If you don't have the right number to begin with, then you're not going to get it right. So. Okay. Do you guys have any questions on that? On lab 22? Just go over, I would just read through it again and just read through the steps and just remember what you did.